do this just for connectivity. So say I want to copy the stream from another flow sheet that I've calculated before. So you click on it. I think it's already clicked, right? Then you go to Input, Define Stream Data Link. Then you click on Define Link. I want to link it to, and then you click on Browse to find a file like A1. And then what stream in A1 do you want to link it to? So just pick a stream, that you want to link it to and say OK. And if you click on Update Now, it'll actually copy all the stream information into your current stream here. But it's OK because So what that'll do is it'll help you, save you some time. You don't have to input all the data, but make sure your component list is the same. Like mine wasn't. I was just randomly picking. This is not a dynamic link, however. If you run the other flow sheet again and the answer changes, and you open this flow sheet, it's going to have the previous answer in there, previous stream. So you would have to go and make sure, go back to the link and say Update Now. So it's not dynamic. All right. So why don't we go ahead? Any questions before we start on the exercise? Can I get a volunteer to do the exercise? Hopefully someone who's never done it, too much before, so you don't go too fast. Yeah.
Elaine's never done it before.
This is working, right?
But I would never use it. I know everybody does.
I went to the restroom. Okay, anybody? Process would. Usually because you're providing data sheets and you need the heat and material balance generated, like the stream data, that would be like your heat and material balance.
So who are the process people in here? I don't know, no one wants to raise their hand.
Hardy? Chris?
Yeah, Chris.
Oh, maybe two of you, both of you come up here. Yeah, you can figure it out. Come on, I don't want to do it. Yes, whoever's in process or close to process. Yeah, where's Paula? Paula. You want? Please. Thank you. I'll walk you through it. So what she's going to do with us, you're going to have to go all the way around, I think, because she's going to trip. I'll scoot over. Thank you. I'll give you a candy. Such great incentives we give here. Here, I'll let you sit down for a second. Oh, of course. Yeah, we'll go through it. And these exercises are written pretty well that you can do it yourself. So go ahead and say File New, and then don't save it. Yeah, just say no. Okay, so you now have a blank flow sheet, and you'll see the reds on there. There's stream, component, and thermal. So it says, through guided practice, you'll build a simulation of the process shown below as part of a chiller plant typical in natural gas processing. And subsequent parts of this example you're going to add on to it. So first part, we're just going to do this, and it says use Payne-Robinson. So they give you equipment data and composition, temperature and pressure, and you'll have a petroleum component. It says C6 plus down here. So that's not in the library, so you'll need to give 2 of the 3. And so let's start and create a new one. Now, you have the unit ops on the right side, so go ahead and let's start drawing. Pick a flash, which is the first one, right? And then click. Yeah, you need to click and let go, and then, click, and then put it where you want it. Then go ahead and pick a simple heat exchanger, which is right down there. Okay. Right there in the middle. Oh, yeah, just put it right, to the right. That's good. And then get a compressor, which is down there. Okay. And then a pump, which you're going to put down here. In this one, I think they... Okay, we need another flash drum after the heat exchanger. Yeah, right there. Okay, now you just need to connect the unit ops with some streams. So click on streams up there at the very top, and then start drawing from like left to right. Yeah, that's good. Oops. Yeah. Okay, good. And it's just one-sided, so yeah, that's good. Go into the feed, and then take an outlet, and then the bottom, go to the pump, and out. And you need a feed to the first flash. Okay, good. All right, and now everything is green except for the stream, the feed stream. You'll see, and then the unit ops. See how the borders are green? So what we'll do is, let's go up and choose. Okay, sure. That one, what do you want to call it? D1 scrubber. Okay. Or just D1, and then you can call it scrubber in the description. Okay. And then that one, C1.
C1 already.
Okay. I'm going to sit down. Okay. Now, let's go in and pick our components. See the little benzene ring? Yeah. Okay. I'll read them to you. Nitrogen, you could just type nitrogen or, yeah. And then click on add. And then the next one is carbon dioxide. You could type CO2. They don't recognize that. Okay. Good. Methane C1 is good, or you can type methane either way. Then C2 for ethane, and propane is C3. IC4 is ibutane, so IC4. Yeah. And then NC4, IC5, and then NC5. Okay, so we still have one more component, and that's the C6 plus, and that's a petroleum component. So click on the left-hand side there, petroleum, and we'll give it the name later. You need to put in 2 of the 3 properties up there, and they gave us normal boiling point and specific API gravity. So normal boiling point is 210, and API gravity is 73. Okay, and then let's give it the name, C6 plus, just so we're consistent. You don't have to, but you know. Okay, say okay.
So these are my components.
Those are your components, so say okay, and then those will be stored. Now, let's go pick the thermodynamic data, which is that little phase diagram, right there. And then they say to use Ping-Robinson, because it's a light system. So it's under most commonly used, and the equation does say so. You can pick either one. And then say okay. And then let's go ahead and go get the red out of the stream. So composition defined, because they gave us the whole composition. So click, yeah, you can give it a name. Inlet gas. Okay, and then click on the red button. Okay, what did they give us? Did they give us total flow rate? So go ahead and click on total flow rate. Then you have 4 times 10 to the 7th. 4E7 I would do. 4E7. Yeah. And then it's standard vapor cubic feet per day. So it's actually... So go to click on units of measure up there and do vapor volume. Yeah. Cubic feet per day. Or over there. Yeah. Okay, good. So we got that. And now we need to put in, see how the composition fields are red? That means we need to give it, I can read it to you. So, and you can use the tab key to to go to the next field. So 1.6, 72.5, 11.5, 6.75. You type faster than I read. All right, 0.55. Very good. Okay. Okay, and say okay.
Normalize?
Yeah, it doesn't add up to 100, so yeah, normalize. Very good. All right. Okay, so the pressure is, or the temperature is 120, so go ahead and choose temperature, 120, and then pressure is 205 psig. So you could do 205, yeah. And then you could click on UOM and say psig, and then, yeah, that's good. Say okay. So we have that, we have the streams, we have components, we have thermal. Now we just need to, okay. Yeah, it's very important actually to name your streams descriptively so that when you have it on your stream property table, you can see what it is in the stream 1, stream 2. You know, it's kind of confusing. Okay, and then go ahead and double click on the flash drum, and we'll go ahead and define its operating conditions. If you look on page 7, which is the second page for us, that's the first one is the temperature is 85 degrees Fahrenheit, so choose 85 there. And then the pressure, go ahead and, yeah, it'll be that one. And then choose pressure. And 203. Now, if you find yourself changing your units of measure a lot like this, you can just go back and say, okay, right here. And then go up to the ruler up there. Yeah. And look for pressure, and instead of absolute, just change it to gauge. And that'll do it for the rest of the flow sheet. Okay. Okay, so then the next one is compressor. Outlet pressure is 600, so it's red right now. Yeah. And then adiabatic efficiency 72%. So change that to 72. That should do it for that one.
Okay.
Okay. Now the heat exchanger. Go ahead and double click. Okay. The hot side is the process side, which is true. That's what we have. Okay. And the outlet temperature should be 110. So go ahead and click on process stream. Yeah, that's a hot side. Just want to verify that. Say okay. And then the pressure drop. Yeah. Is there a pressure drop? Yeah, 5 psi. So put 5 there. Okay. Then on the cold side, you could use air or water, right? So click on utility stream and say you want to use the utility air. This is air cooler. Inlet temperature is 80, and then outlet is 100. Basically, it'll just calculate how much air will go through to meet that cooling duty. Say okay. And are we missing anything?
Thermodynamic system.
Oh, yeah, it'll just use Peng-Robinson. That's fine. We're going to use Peng-Robinson for everything. And that's where you can select, if you have more than one system in your simulation, you can use different thermals. So the specification is the only thing that's red. And in this heat exchanger, it says the outlet temperature should be 110 degrees. So is there a hot outlet temperature? Go down some more. There you go. Hot product temperature. Yeah. Should be 110. Okay. Okay, good. And then it's all blue, so that one's defined. And then the knockout drum, it says it's to be a flash drum with no change of pressure and no duty. So basically pressure drop 0 is fine. Yeah, go ahead and name it knockout drum or whatever you want to call it. Oh yeah, because it's the label doesn't do it, but the description does take space. So delta P of 0 is okay. We'll leave that the same. And no change of duty. That means it's adiabatic. I don't know if that's how they word it. Go ahead and see if you could say adiabatic or duty equals 0. Okay, duty equals 0. All right. And then the last one is the pump. Oh, that's okay.
I want to. Okay.
Yeah. And the pump outlet pressure should be 550. So outlet pressure.
PSIG.
Yes. Oh, 550. Okay, and then the efficiency is 65%. Efficiency's over there. Yeah. Okay, so basically you set up this whole thing. And now everything is non-red. And you'll see that little play button, you know, like on your VCR. That's to run it. So click on that, and then everything turned blue. And the computer is so fast, it turned blue just like that. But if you had like a recycle, sometimes it takes a long time to solve. You'll see like it'll go red, blue, you know, like all around, and you could actually see the sequence it goes through. Okay, so you're finished, and what you could do right now is, let's see if they added it. You could get the results, and let's compare it with the results here. So go ahead and output generate report, and just give it a name like Paula or something. Or Chiller 1, something like that.
I don't know.
Anything. Just as long as you know what it is.
So on desktop is okay?
Sure. I think they reformat this computer anyway. Okay, so you'll see in your output, the first part is your input in the weird keyword format. Go ahead and scroll. You could double click on that blue bar on top and make it big. Yeah. And then you'll see how it says problem solution reached. You always want to see that. Well, you saw it was all blue, so you know it was problem solution reached. And they used to charge people based on the simulation units. Like that's how much you would pay for it. But now we pay a whole license fee for, you know, years and years. So that's why you see this run use 20.91 Pro 2 simulation units. That's how much they used to charge people. Okay, and then you'll see how much time it took. Oh, that's kind of not that important. And then you would just go ahead and page down, and you'll see all your components and all the properties for each component from the Pro 2 library. And if you keep scrolling down, you'll see that unit op information in each section. Like that first one was the drum. Yeah, and then here's the compressor. And you'll see inlet, and then there's the isentropic results, and then the outlet. Now, did they give us a goal to look at? Like, what are we trying to figure out here? Okay, so look at the pump 1 output and see if you get let's look at the work and the head, the pump head. So these are your streams, so you need to page up a little bit. So pump was called pump, right? Yeah, so go down until, you could do edit find pump or whatever, or just scroll down. I think it was after, yeah, there it is, unit 4 pump. So, let's see, adiabatic, the work. So work is 2.43, so that's what they got, so you did it right. Okay. So that's basically, you know, that's how you look at the results. Now for us, it's probably more useful to make a stream property table and put it on the flow sheet. So go ahead and click on Pro 2 again down there. Yeah. And you could double click. Yeah. And then scroll all the way down to the bottom on the unit ops. On the right. Yeah, that one. Yeah. There's a stream property. Stream properties. Yeah. Go ahead and lay one down. And then double click to open it and add all the streams. Just click on add all, or right there, yeah. Say okay. And then you could make it bigger, like just drag a corner. Yeah, drag a corner. See, so that's a stream property table. And then you could take that, you know, to Excel or whatever, make your heat and material balance from there. Of course, you're going to need more information. Now, you notice there's no transport properties. We didn't turn that on in our thermal section. If you go ahead and click on that phase diagram again up there, and go ahead and click on modify. We already have Ping Robinson selected. And see how the transport properties right there? We didn't ask it to, if you wanted to have it computed, and we usually do, so you would check that and then run it again. See how it turned non-blue? So that means you changed something and you can't use the results. So click again and it should compute it. Now, by default, it doesn't print it out. You need to ask for the transfer properties to print out. And we can do that through the options. Oh, down top, yeah. And then stream property list. And you would go through, remember I picked one. I named it Hamid, and then we went through and picked. And so that's how you would do it and make an output. So pretty easy, right? Any questions? She did it really fast, actually. We kind of did it kind of fast. So that's how you would set it up. It's not that difficult. I mean, the hard part is actually seeing if you get good results. And this case, it solves very quickly, and it reached a solution. But sometimes you're going to get one that doesn't reach a solution. It's going to be red, and you're like, oh my gosh, what do I do now? You'll see that with columns a lot because it has more parameters it has to solve. And we'll talk about columns next week. And I will give some troubleshooting hints, but without actually using this, you're not going to really appreciate what that is. I mean, you have to actually use it and run into problems, and then you understand why you need to troubleshoot and why good estimates are important. Any questions on that? If not, I think we'll call it a day and then have a happy Valentine's Day.